All right, so we're going to talk about solving two-step equations. We already talked about one step with rational coefficients. This time we're going to find out how can you use a backward problem-solving strategy to solve two-step equations. All right, so let's take a look at our first example. Ariana went to the movies with some friends, and the tickets cost $6.50 each. They spent $17.50 on snacks. How many people went? Well, let's find out. So the total amount that they paid, you need to know that, was $63. Okay, so there's some important information. So let me take a look at what I've done here. I said, look, the number of tickets times the price per ticket. Okay, that would find out how much you spent just for tickets, right? How many tickets you bought and what each of them was worth. We know each of them were $6.50. I just don't know how many people. The other thing I know is I spent $17.50 just on snacks. And the price for the tickets and the snacks together, all that money spent, will give you your total cost. All right, so let's take a look. So I've set this up. I said, look, the price of the tickets were $6.50. How many tickets? I don't know, so I used the variable t for now. I also know that I spent $17.50 on snacks, and the total was $63. So what I can do is, right away, I identify my variable term. That's right over here. I look next to it and say, look, I don't know this yet, but I do know for sure that $17.50 was spent on snacks. So why don't I subtract that from the total? If I subtract that from the total, this amount here tells me how much I spent just on tickets, okay? Because that's the total minus what you spent on snacks. That's the total just for tickets. So, okay, $6.50 times t is equal to $45.50. I divide both sides by the ticket price, right? Because I really want to get this t by itself. So divide by $6.50, and I find out that my answer is 7. So therefore, Ariana, 7 people went to the movies, including Ariana. Okay, so 7 is how we can figure this out. How can I double check? I could use my calculator and go 7 times $6.50, add that to $17.50, and I should end up with $63. We'll be spending some time in class showing you how to solve this using a model, okay, called algebra tiles. So let's take a look. If I use algebra tiles, what you need to know is that the variables, there's 2 variables here, 2 x's, 2 unknowns. So there's 2 unknowns. I've got 3 positive 3's. I know those are called constants. And then I've got 7 constants on the other side. So I want to isolate the variable x. I want to organize the variables, basically kind of get just these 2 all by themselves, okay? And constants on the other side. So how do I do that? Well, look, I've got 2 different types here. I've got letters and I've got numbers on this side. Here I just have numbers. So it'd be really helpful if I could just get rid of these 3, clean that up. And so that's what I do. I will go ahead and remove 3 constants from this side, but whatever you do to one side, you must remember you have to do to the other side. So I would take 3 from both sides to keep it fair, if you will. Okay, so if once I do that, I notice that, hey, look, I've got 2 x's. I just kind of rotated them. I've got 2 x's, and then it's left over with 4 spots left over. So I can separate those into 2 equal parts. I can cut it in half. And I can find out if I cut that in half, that 1x is equal just to 2 spots. Just to 2. And then I can double check my work. Okay, if I take 2 and I plug it back in, 2 times 2 is 4. 4 plus 3 is 7. And that works out. And I showed you that right over here. Right? 2 times x plus 3 equals 7. I said x was 2. I plugged that in. I then simplified it. And then simplified one more time. So now this is a little bit faster way. This is solving using symbols. So what do I mean by that? Well, look, here I go again. I've got 3x plus 2 equals 20. I find my variable term, which is right over here. I look right next to it, and I said, this constant right here, this plus 2, I got to get rid of. So let's get it out of there. Okay, so I subtract 2 on both sides. I do that, simplify. 3x equals 18. So, okay, good. I've got my variables on one side and my constants on the other. But I need to get it all by itself. So if I cut that into 3 different ways, divided by 3, I divide this side by 3 as well. I end up with my solution 6. But never good enough just to stop there. You want to check your work. So I go back to my original problem and I go ahead and replace the x, substitute it with the 6. 3 times 6 is 18. 18 plus 2 equals 20. And 20 equals 20. So that works out well. Let's do something a little more challenging. So here we go. I take a look at this. Once again, I find my variable term that's right over here. I look right next to it and I say this constant is the one I want to get rid of. So it's already a negative 3. I'm going to add 3 to both sides. Add 3 to both sides. That allows me to eliminate these 2. Those get eliminated. I get 1/4 n. This turns out to be 28. Now, if you remember from last chapter, how do I get rid of a rational exponent? I multiply it by its multiplicative inverse. So I flip it around, 4 over 1, and I do that, multiply to both sides. If I do that, cross cancel this left side, it leaves me with 1n, and this right side will leave me with this larger number, 112. So I think 112 is my answer, so I plug it in. I check to see, substitute. If I do the math here and do some cross canceling, sure enough, 28 minus 3 is going to give me 25, so it works out fine. All right, so let's do one where we have the variable on the right-hand side. Not a big deal. I find my variable term. Here it is right here. I look, okay, I'm on the right-hand side of the equation, so I have to continue to look on the right-hand side, and I notice, hey, wait a minute. I've got this negative 5 right here. Get rid of it. So I add 5 to both sides. Add 5, I end up with that. I notice, okay, look, I got this in front of this coefficient of r, so I need to use the multiplicative inverse. I multiply by its inverse. So instead of 2 over 5, I have 5 over 2. That allows the right-hand side to turn into a big 1r. And this left-hand side, you do some cross-canceling, you end up with 30. You can plug that in to check to see if it works. So here's the original question. I just put it down over here. And I say, look, substitute r with 30. I do that. Does it work out? We'll simplify, take some steps to simplify, and you find out that 7 equals 7. Okay, I'm going to go ahead and make a second video, so if you need some extra help, I would suggest you do that, especially if you didn't understand these questions here.